Live now, sir. Thank you.
Okay. Good afternoon to all. This is the second session of the day and fifth session of the conference on XR and immersive technologies. Uh, there are certain hygiene instructions which we have to follow. They are that all the attendees shall be kept on mute throughout the session. Webinar shall be recorded and posted on the TSDSI website after the event is over, after the conference is over. Kindly post your questions in the Q&A tab if you have any questions to ask. You can interact with your fellow attendees using the chat during the session. You can visit the exhibit booth in between the sessions to know about the TSDSI works. You can visit launch facility also for networking with your fellows, and this facility is available till the end of this particular conference. Next, please. This session has got two co-chairs, Mr. Suresh Chaturi from Samsung and Mr. Pratipta Bishwas from IIC Bangalore, and Rajesh Kapoor is the convener of this particular session. Next, please. About Mr. Suresh Chaturi ji. Suresh ji is the vice chair of the governing council of TSDSI and also rules and regulation committee of TSDSI. He is senior director and head technology standards at Samsung Research Bangalore. About Pradipta Bishwasji, he is associate professor at Center of Product Design and Manufacturing and associated facility at Robert Bosch Center for Cyber Physical Systems of Indian Institute of Sciences, Bangalore. Now I hand over the proceedings to Mr. Suresh Chaturiji for the next course of this particular session. Over to Mr. Sudesh Chaturji.
Yeah, thank you, Mr. Rajesh Kapoor, for kicking off the session. Hello, everyone. Welcome to this session on XR and immersive technologies. This is the one of the many sessions that we are doing as part of TTDD, which is the TSDSI Tech Deep Dive Conference, which is our flagship conference that we do annually at TSDSI. And I'm really excited to welcome all of you to this session on behalf of my co-chair, Professor Pradipta Biswas from IAC, and myself and the entire organizing team. As you know, extended reality is a combination of human and computer generated interaction, uh, you know, mixing the real and digital worlds, and it brings a very new paradigm to how we interact with things and humans in a mixed mode. XR as a term is a superset of many technologies: augmented reality, virtual reality, and mixed reality. We generally refer to it as XR, and we believe XR is a technology that is an emerging technology and leads to several immersive experiences, such as digital twin, and now there's a lot of talk about metaverse, and also very importantly on how it meets some of the applications to support accessibility. Now, with 5G advanced standardization, and also if you look at the 6G research trends, XR is very prominent in these core technologies, and we think XR will be a fundamental enabler for a number of applications over the coming decade and beyond. And having said that, there's a lot of research that is ongoing within the industry, in academia, and in the research forums on the latest work on XR and some of the standardization aspects for XR technology. Given the importance of this technology, we believe it's very crucial that we start engaging on XR, and we truly believe that it will transform the way we experience and interact with the physical and virtual world. And last month, I want to just mention that when I was at the India Mobile Congress, there were a lot of use cases already being demonstrated using immersive technologies. And I know it's at the beginning stage, but it does seem like XR is going to be a killer technology, I hope, for the coming years and decades to come. So, in this session, we have a number of leading global experts from around the world, and I just quickly want to uh, present you the schedule of this session. So, we will start with a 10-minute expert talk from Professor Pradipta Biswas, who will be talking about some of the latest XR research at Indian Institute of Science. Followed by that, we have four keynote speaker sessions. The first one is from Professor Pilar Orero from University of Barcelona, Spain, who will be talking on standardizing immersive experiences for all. Followed by that, we have Thomas Stockhammer from Qualcomm, who's going to explain the progress on XR technologies and standards. And then we have a speaker from Nokia Bell Labs, Japan, Binoy Sabire, who's unfortunately not here live, but we have a recording presentation from him. And then we conclude the keynotes from the speaker from Microsoft Research, Mr. Manohar Swaminathan, who's going to talk more about human standards for human capability and metaverse in XR environments. So, following the keynotes, we have 45 minutes panel discussion that I will be moderating, and we have Professor Pilar and Thomas will continue on, and we have Mr. Girish S. Pujar, the scientist at ISRO, and we also have Big Naraj from Nokia India Standards. So this is the plan. And then we do a closing. So the whole event is planned to be approximately 2 hours and 15 minutes. So I hope you can stay on for the entire event, and I look forward to some really engaging conversations around XR. So with that, I think we can. So here again, the brief images of the keynote speakers we have. As you can see, it's quite diverse in terms of the people that we have, and I'm excited about it. So if you go to the next, I think we can go right into the expert talk. So let me introduce the expert talk speaker and my fellow co-chair, Pradipta Biswas. Again, I'll just keep it brief, but Professor Pradipta Biswas is an associate professor at Center of Production Design and Manufacturing and associate faculty at Robert Bosch Center for Cyber Physical Systems at Indian Institute of Science. So with that, I would hand over the floor to Professor Pradipta. The floor is yours.
Thank you, Suresh, for the kind introduction, and thanks all attendees for joining this session. So I will give try to give a 10 minutes.
Like you're muted, Professor Pradipta. We can't hear you.
Am I audible now?
Yeah, we can hear you,
Yeah,
sir.
you are audible here. You're audible here.
Okay, thank you. Right. So I will quickly go to my presentation.
Yeah.
Can someone just confirm the slides are visible?
Yes, they're visible and we can hear you well.
Very good. Thank you. So for the next 10 minutes, I will take you through a set of projects we are working on IISC, and I particularly chose a bunch of applications which on the face value will look very different, and with very different stakeholder or sponsoring agencies. But I hope that will give some overview of the application area, and all these applications, whatever diverse they are united by the fact that all of them are using XR technologies. So in these 10 minutes, I will not go into very much technical details, which you will get in the upcoming keynotes, but it will give you an overview, and maybe it will also make you interested to physically visit IISc at some point in future. So the first case study we are developing with the funding from Collins Aerospace Systems. So here we developed a mixed reality based assembly process assistant. What does it mean? That here the person is trying to assemble a pneumatic cylinder, and the process involves developing a set of holograms of individual component of the system and detecting them in real time using deep learning computer vision models and developing interaction technologies to indicate that which component to pick up next to develop the full component. So here you can see there is a set of white components which are physically 3D printed components. Those are reality, or maybe sometimes funnily we tell the real reality. And the blue and green components are holograms created using Microsoft HoloLens 2. And the green component has to be picked up next. Moving on, a very different application. And here we are trying to work with a bunch of students who are severely speech and motor impaired. That means they cannot talk and they are quadriplegic. But using again these XR technologies, we are trying to teach them to operate robotic systems as well as to develop many of the which is non-electronic technology. So this video is recorded on 17th and 18th of October at IIT Madras Research Park. And here this person in the top left corner, she is using her eye gaze to operate this toy car and trying to hit a target rendered on the screen. And same thing, she can also, here you can see a screenshot and you can see that it's a use of augmented reality technology, more specifically video see-through display, which is rendered just on a keyboard. And the same interface they can also use to operate a drone. And our aim is to bringing playfulness in this augmented virtual reality interface and use it to further train them for more meaningful application using robots, and which will be useful for their education and rehabilitation. We are doing a workshop end of this month, which you are most welcome to attend this well. So this is the present situation, and we are trying to automate it using AR/VR systems. Moving on, this is a third application. Here we are working with British Telecom, and we are developing a simulation of their workspace. And BT has a lot of real estate, and they are interested into investigate the room occupancy feature. So on the left hand side, you can see a video from our lab where we are using computer vision technologies to detect the presence of a person and his posture. And in real time, we are mapping it in a VR digital twin. And in the right side, you can see a simulation video where we can simulate different room occupancy level. And also we allow to take a virtual walkthrough in real time with the room occupancy feature. The fourth use case, we are working on developing a advanced driving assistance system. So you may come across, there was a press release a few weeks ago between Microsoft and Volkswagen of exploring HoloLens for uh, investigating new generation of ADAS. So here we are comparing takeover requests. So imagine that you are driving a semi-autonomous vehicle, but at some point you have to take over control, and the ADAS is indicating you with the lane designation and obstacle on the road. So here we created a set of obstacle using holograms, and we compared both HoloLens-based ADAS as well as screen-based ADAS, and see that how quickly people can operate that ADAS and take over control when they are operating a mobile robot using the ADAS interface. And we presented some results in the Automotive UI conference last month. Uh, we are also working with various defense agencies, and in fact we are also designing the crew cabin module of the for the Gaganayan program. We got a project from ISRO human space flight program, and this flight simulator is also we set up in our lab. And here we set up both a desktop flight simulator and a virtual reality based flight simulator. And we are working with various defense agencies and Indian Air Force colleagues to develop automatic system for estimating cognitive load of pilots as well as we are contributing to the next generation of cockpit design by integrating new modalities of interaction, and also comparing that how VR simulator will be useful for both pilot training and as well as new technology development. And the final case study is from the healthcare domain. So here we developed a collaborative robot during the COVID pandemic. And this robot can be operated using both augmented and virtual reality interface. And here the doctor can will be able to maintain safe distance from the patient. Here you can see that we recorded this case study in our Institute Health Center. So using this video see-through interface, that doctor can operate this robot, which is completely 3D printed in our lab, and can take vitals like temperature, pulse oximeter, and faces or the picture of different body parts of the user. And it also support tele operation in terms of a virtual reality interface to operate this robotic arm. So to conclude, our research combined IoT and computer vision technology with XR technology, and that leads to many new use case studies. And in face value, we looking at very different case studies from flight simulator to inclusive human robot interface and built environment and so on. And we are also investigating for our research purpose different combinations of modalities like eye tracking, hand tracking, and augmented virtual mixed reality technology, and try to see that what are the best possible solution in different situations. So with that, I will stop talking, and thanks again for the opportunity, and I'm looking forward to the upcoming keynotes. Thank you.
Thank you, Professor Pradipta. It's an excellent presentation, and uh, I think you have covered at least 4 or 5 various sectors of the use cases like healthcare and automotive, and also manufacturing. So it's very interesting to see the research that you're doing. I do not see any questions in the panel, but perhaps you can post the links to your work on the chat window, so people can go there and look for more information. So thanks again, Professor Pradipta, for the excellent talk and introduction. Now, I think we should go on to the next part of the session. So we move into the keynote sessions. So the first one we have is from Professor Pilar Orero. The title of the keynote is Standardizing Immersive Experiences for All. Professor Pilar works at the University of Barcelona in Spain in the Transmedia Catalonia lab. Uh, as you can see, she's a prolific researcher in this space and has written many books, lots of papers, and also worked on the standardization front. So welcome, Professor Pilar, to this session. The floor is yours for your keynote.
Thank you very much. And I would like to thank everyone for inviting me, and also for the amazing organization. I am very, very surprised of how well it's organized and how well it's running. I would like to present. Can I but my presentation? Now I can present. Okay. Can you see my screen?
Yes, we can see the screen well.
Fantastic. Okay. So what I'm going to present, it's to do with accessibility. How are the requirements for end users to consume content in 360, and how these users, usually who are disabled in a sensorial way, either blind or deaf-blind, so they would need what they would need to be able to consume content in 360. So that is the research that we've been doing for the last 5 years. The research is being done paid by the European Union, and basically there is these 3 projects: GreenSend, Mediaverse, and IMAC. They're the ones that basically doing this work. The way we work, it's bottom up. What I mean is that we ask end users, how would you like, what are your expectations? And from there, we draft some prescriptions or some ideas, and then we develop the stimuli, and then we test this with them. So that's the way we do it. We do that in multidisciplinary teams. So, for example, I am a translator, philologist, though we do have a psychologist, we have engineers, we have. So it is impossible to do this work just one team only, because it is too complex. And what are we doing from the content and the data that we gather from this project is that we feed two standardization agencies. The first one is ISO, and is the standard, the 27130, which is accessible XR. I am the convener, and the ITU Common User Profile, and Professor Pradipta Viswas is the convener for that one. So anything that is coming out of this research, we feed it into these standards. The first problem that we had when we started working, I don't know if the first problem that we had, the videos are not working. Never mind. The first problem that we had when we started doing with research in XR or VR, it was that we assumed that everything that we knew from 2D was transferable to VR. So, for example, the reading speed of subtitles, the listening to audio description, it was exactly the same. So we only had to just get what we had from 2D and pass it on to VR. And the truth is that is very far from the reality. And we learned that in the hard way, but just mistakes and mistakes and mistakes. The problem is that while in 2D, the person that is watching is passive, it's just there, sitting down, and a media is projected to them. In VR, the end user can just go round and round and see anything that is presented to them. So that it was the very first problem that we had. Then we had to think on how the quality of what they were watching was any good. Is the vision exactly the same when in the field? No, it isn't. In 2D, all the field of vision is exactly the same. In 360, the field of view, it is not the same. So then we had to establish a VR field of view where we would be performing the tests in that field of view and not in the periphery of it, because the quality is really bad. And that was very, very important, mainly for two accessibility services. One is subtitling and the other one is sign language. You could not place a subtitle or you could not place sign language away from the field of view. And that we learned by mistakes, basically. So then in the picture on the left, you would see how we created an application where we place the human at the center of the 360, and then we simulate the subtitles, or we simulate the field of vision, and in that way we are able to generate content to then test. Another problem that we experienced by consuming media in 360 was that the person who was speaking is not identified. The end user can walk or look around, but if he is a person who cannot hear, he will not be able to understand who is the person who is speaking. And that created a big problem. So we had to somehow identify who is the speaker. So that is one of the issues that we've been trying to understand. What is the best way to tell the viewer who is the speaker and identify the speaker? Here, for example, the way to identify the speaker is by arrows and by putting he is the speaking and he's not speaking, or the speaker is to the left. Another one you would see is in the blue subtitle. The blue means that the speaker is associated to a blue color. And then you have the arrow that tells you that the speaker with the blue color is blue subtitle color is on the left. So we have a double input. One is by color and the other one is by an arrow. So those were some of the identifications that we've been testing. The other one is the guiding mechanisms. Exactly, just go to the left, go to the right. So arrows is a possibility, colors is another possibility. So at the very beginning of any video, each speaker would have a color. Some European countries, they have this way of identifying speakers. Some European countries, like France, for example, don't have this way of identifying speakers. So again, this is not a universal, and in fact, in Europe, it has created problems because the colors are not a standard form of user identification. But nevertheless, we have tested it, and we have tested it when there were more than one speaker, because that is one of the problems. It is very good when only one speaker, one person is speaking, and then it's easy, more or less, to understand who is the person speaking. But when we have more than one speaker, how we identify this number of speakers? The other way that we have tried to identify speakers, apart from arrows and apart from colors, and apart from trying to place the subtitle close to the person who is speaking, is the bottom image, and that is through a radar. And the radar would show you the different colors, which means the different speakers, and it would tell you where you are in relation to the people who are speaking. So those are the very different ways that we've been trying to do the speaker identification and the guiding mechanisms in 360. From all that research, we came out with some conclusions. One is that the subtitle has got to be locked under the speaker. In this case, you can see the speaker in white. It has the subtitles under the speaker, but the speaker on the middle and the speaker on the right, the subtitles are put on the top of the speaker. And it was found by a number of tests is over 400, is that they want everybody, but that is not news, everybody likes what they're used to. So even though we thought that people would like to have the subtitles on top of the person who was speaking, everybody likes what they're used to. So they want the subtitles under the person who is speaking, which of course compromises many problems at the time of, for example, covering the face or covering the lips, or for example, if we're watching sports, for example, in football, the ball, the subtitle covering the ball when it's entering the goal, for example. So anyway, what is being found is that people prefer the top, the subtitles not at the top but at the bottom, and also that the subtitle is locked, which I mean is that when the speaker is talking, the subtitle is in the speaker. It is not where the end user is looking. So you don't carry the subtitles with you. The subtitles are there, and you go and find who is the speaker, and the subtitles will be under the speaker. Another problem was, again, how we present the number of speakers. As I said earlier, if everybody has the same color, it doesn't matter if it is blue or if it is white. On the left, we have that there are different. So we have, for example, the speaker at the bottom is following the subtitle of the speaker, while on the right, we have all the subtitles that are happening at the same time piled up. Yes, it's very good. It's easier to read in this way, on the weight on the right, but the problem is we don't know who is talking. So even though even though some companies, big, large companies, are saying that this is the best way to represent subtitles of multiple speakers, we have found that this is not true. That subtitles should be, again, at the bottom, not here on the top, and locked on the speaker who is speaking at the time. So there you are. that is a very different way of projecting the subtitles. So the idea would be that each person that is speaking at the same time would have the subtitles there, and of course they would not be covering the faces as they are here, or covering, they would be under the speaker, but that is the way we would be finding the subtitles. Then when you go and find who is the speaker, you would see the subtitles at the bottom of the speaker. A completely different story that we found out is that while we were doing the research, we realized that there is no communication there is no accessibility activated in the different stages in the workflow. For example, a device is the head-mounted display. The device had no way to communicate with the end user. So, for example, you put the device on, and a blind person was not able to communicate with the device, the device didn't give any information to the blind person. For example, put your head down if you want to start the menu. And then the menu was read aloud, and it would say, put your head down when you want to make a choice for the menu. Or it did have no connection with anything that was any spoken orders for the device to behave in one way or the other. So even though the video had subtitles, or the video had audio description, the end user was not able to activate the head-mounted displays to see or to watch the video. The other problem that we realized is that the platform, the EPG or whatever platform there, was not accessible either. So even though the device was accessible, the platform was not accessible. So the choice of services, the choice of languages, the choice was not accessible either. And there was no communication between the platform and the devices. And if we go one level lower, we also saw that the media player inside the platform was not accessible. So the media player had no visible buttons to activate the closed captions or the subtitles. They had no way to activate the audio description. It had no way to activate the sign language. So again, we are now 3 layers down to make of difficulties, of barriers, where the end user was not able to activate anything that was inside of the media player, any media content that was accessible in itself. And at the end, we have the multimedia content. And the multimedia content, of course, needs to be made accessible by subtitles, by audio description, by sign language. And also it has to be signed, the metadata has also contained some information about this multimedia content, that it is accessible. So the media player can recognize and activate, and then the platform, and then the devices. So we also realized that not only the subtitles were accessible or nowhere accessible, and the end user was able to go and find the subtitles, but also we realized that the media player, the platform, and the devices were not accessible in itself. So the tests were not done independently. The test had to be very much guided in order for the end user to understand what was happening there in the head-mounted display. And the other very interesting issue that we realize is that we are testing from Europe content mainly produced in English, while in Europe, English is only in 2 languages, in two countries, in Ireland and in the UK. The rest of Europe does not speak English. In fact, they speak different languages, very small, a bit larger. And in some countries, they speak more than one language. It is the same as in India. There are many, many languages spoken. And the languages also, they are official languages inside the country. So the people have got the right to watch the media content with accessibility in different languages. And we realized that because the media content is quite often in English, The big streaming platforms, they don't realize that they need to be translated into the many languages in each country. So, for example, to put an example for Spain, in Spain there are 4 official languages, while the big, large platforms, they only consider 1. And that goes for many other European countries. So that is one, this is why on the left graph, I have put translation in between the media player and the multimedia content, because translation, it is something, it is a service that needs to be done always in Europe to make sure that the content, the media content, is accessible, because you may speak German, but you may not speak English. So again, there you have linguistic accessibility that you need there. This is all the findings that we have up to now. We are working a lot, but it's very, very slow. And because we have to create both the media content and the accessibility to test. We will be delighted to team up with anybody in India. And thank you very much.
Thank you, Professor Pillar. It's been an excellent presentation, very insightful to see your findings. Yeah, looking at the Q&A box, I don't see any questions at the moment. But I believe we can pick up some of this during our panel discussion. I think it's very interesting because accessibility is something that probably people don't think from the ground up, and it's very interesting to see what you're doing, and probably maybe we would be interested in what aspects of those need to be standardized. We have some people here from 3GPP, for example, who might be interested in looking at these aspects, and also in TSDSI. So thank you very much for your time and the excellent presentation. So now we move on to the next keynote speaker, Thomas Stockhammer.
Suresh, thank you. Can you see my screen and hear me well?
Yes, if I may just briefly introduce Thomas.
Sure.
Yeah, I guess we have to go to the other presentation, but let me just quickly introduce Thomas. So Thomas has been doing standards, I guess, for us as long as he's been working, I assume. But he is with Qualcomm. Joined in 2014. He's the senior director of technical standards. Again, Thomas has co-authored a number of research publications, several hundreds research publications and patents. Has also held a lot of leadership and rapporteur positions in various standards organizations. And one thing I want to mention also is he's part of the team that has won the Emmy award for Dash standards, which is very special. So we're very glad to have you, Thomas, and we look forward to your keynote. So over to you.
Okay, let me share my screen again. Okay. Share presentation. Okay, so does it work again?
Yes.
Okay, thank you, Suresh and colleagues, for inviting me for the introduction and for organizing such a nice event. It's a great tool, actually. You can do a lot of things, so I believe you should use this in 3GPP as well. What I'm going to speak about is technologies for the metaverse, and XR is a part of this. There's AI, there's 5G, and basically how these pieces fit together from the view from Qualcomm into creating experiences. And what I was very grateful that the colleagues introduced use cases already, because that gives an idea where we want to get to. Quickly here, there's a right-hand side, a bit of an introduction about myself. I'm just going to speak a bit about what the metaverse could be, what are technologies for the metaverse, Then talking about the standards, and I mean that only covers and scratches on the surface. And I also want to show a bit on how we as Qualcomm contribute to metaverse experiences and so on and so on. As an introduction to the metaverse, and as I said before, I believe it was excellent to see the use cases of the colleagues, the academic colleagues before looking into many different aspects. And we see XR in the dimension of where you have virtual reality, which basically is much more, you're getting in a separate world, right? And then in the separate world, you enjoy things like gaming, entertainment content, but also in the enterprise domain, you see relevant topics as we have seen before. Much more connected to the real world is the AR, where you basically need to build overlays and connect to the real world and basically still do new experiences. So also you have use cases that come out of the consumer business and the enterprise. And we believe all of this is something that contributes to the to XR and metaverse. And then you can put other aspects that relate to the metaverse on top of this. What I picked up, I had an earlier conference with a colleague from Meta, Joe Kim. He's the head of seller standards in Metaverse. And basically, it's always good to take a bit of an outside perspective when you do your requirements. So this is how they, from Meta, define the metaverse: a set of virtual spaces where you can create, explore with other people in the same or different physical spaces. And again, on the right-hand side, you see different types of use cases, just illustrated by some type of comics or illustrations. Let's go a bit into the technology. So now experience something like this. We talk a lot about HMDs, and Qualcomm is centric to this, not building the devices, but building the internals to this one. And so all of the what you see on the right-hand side is very critical. So there's basically a couple of aspects that need to be always aware. It's power consumption of such devices. It's the issue of heat dissipation. You have a very ergonomic and wearable devices, and then basically you have significant processing. So heat dissipation and power consumption is continuously one of the core topics when you talk about going to devices that are mounted on your head, and you also want to have ergonomics that makes this light enough to not be hampering movement of the users. The second aspect is that we see that all of these experiences are heavily connected, right? Because you're interacting with other colleagues, you're interacting with a network which creates these experiences. And so this requires low latency in order to get into the interaction mode, and the immersiveness. And secondly, also, you need symmetric bandwidth that basically goes upward and downwards. And the third topic is consistent quality. So very much that if you look into how Meta perceives this, and I have taken this from them, it's a consistent approach, also how we see it. So now the metaverse from more the attributes, it's something that basically what you see here. It has a lot of aspects. This is technology centric, but it's also connection of real virtual worlds. It has aspects of what we know from the internet. So it's an open platform. So the openness is important. And it obviously is not that you would be by yourself in your playing your game by yourself. It's very social. And we expect that there will be a multitude of opportunities to socially interact within these aspects of metaverse technologies. And one aspect is also, I mean, as there is kind of one internet, we hope that there is an ability to also create one metaverse. And that speaks very much to the openness that we are looking to. So, but now what I want to dive a bit is what are technologies that enable this, and then basically come back a bit to the end on a couple of other things. So technologies for the metaverse, these are a couple of things I want to present. One is AI, contextual awareness. One is boundless VR and boundless AR. And I go a bit in what this means. Not spending too much time on here, but if you have a device that is mounted and you want to basically be in an AR, VR, AR workflow, there's a simultaneous complex processing to create these experiences. And as you can digest it a bit later and look into the details, but there's an issue of sensing the world, seeing the world around you. There is aspects that you basically recognize, do computer vision. You collect content from the network. You need to render this, and then you basically also operate on personalized actions and so on and so on. And all of this needs to be integrated into a device where you as said, you don't have you have design constraints, so there's significant issues. And if you go through the details, you will understand that this is a heavily complex processing that requires smart integration to make this work. One step further, I just a bit on a partitioning of the architecture. You have different aspects that are integrated in such an AR device that would be lightweight, and you basically have a compute aspect. So we heard about computer vision, tracking, and so on and so on. You have a connectivity aspect, and you also have aspects that relate to sensing. And what we see today, that distributing this across the device, you need basically separated processors, and so on and so on. And secondly, that you also need to distribute it into the networks from your phone to the cloud is very important. So again, this just shows the complexity of the technology, but also it gives quite many engineering exercises and to some extent also standardization exercises to make this work. A key technology and topic, making it a bit more explicit, is the distributed compute. And what we're basically seeing is that we need to have certain processing being running on the device, perception algorithms, for example, for tracking. And this information is then provided back into the network to a cloud or an edge server that then runs a game engine. And then you have compressed rendered frames that are basically directly mapped to your iBuffers. And on the receiving end, you basically just do the final post-processing in order to render these frames properly. That obviously requires that you have a latency loop that is not hindering the immersiveness, right? So, and we know something like this end-to-end loop requires like 60 to 70 milliseconds from the post to the renderer. And then you can do some final post correction in the device. So you need to have workflows and networks that basically speak against these latencies. And obviously, this is media data, so you also have bandwidth requirements that go up to the several tens of megabit per second. So basically, the boundless AR is then now a combination that is basically running certain devices functions on a smartphone, and then you have a tested AR glass, as you would say here, but then you also want to offload data into the cloud and server. And that's where basically the complexity and the engineering and also the interoperability aspects start to happen. So where basically how do you distribute? And it's not that one size fits all. There is different use cases. And secondly, also, how do you create interoperability across these different devices in order to make sure that they can cooperate? So we have been working, and one topic is basically using 5G as a connection to AR glasses. And there's a couple of work topics that are progressed internally, where we also work with partners, where we want to optimizing edge processing, improving schedulers in order to meet the low latency, low power consumption, and then also a more direct access to the physical layer, to the modem, in order to reduce the latency, but also in order to get specifics of the traffic being connected to the physical layer. So there's quite some work in our research departments, and we bring this to standards. We see this evolution from more clumsy standalone headsets that are tested and so on, more and more into a platform that is more seamless. And that is also where these 6G research vectors, the metaverse, the connection of digital worlds, virtual worlds, and physical worlds come together. So this could be a completely new next platform, what we are seeing beyond the smartphone. And potentially, hopefully, at some point of time, a standalone and being directly connected to the network. So that's kind of the technology aspect, and that just scratches the surface, as I said. Let me check on time. I believe I have another 10 minutes to go. So now, what are we doing for standards? And an interesting aspect is basically to understand that there is many standards, and we monitoring these, and I have a couple of those here, which are listed from Open Geospatial Consortium, WCC, VRM, IEEE, this works, Spatial Web Foundation, XRSI, and so on. So, and that really just scratches the surface. We have picked in Qualcomm 3 standards organizations, which we believe are creating significant technology enablers to the metaverse subjects. And they're very close to what we generally work on. It's the hardware, it's the integration. So 3GP, looking at architectures for split rendering, as we spoke, conferencing system, power savings, capacity enhancements. We have picked MPEG as basically working on core compression technologies to basically deliver media across the network and make it basically digitally represented and deliverable. And then there's a significant amount of work in the Kronos group to open up the device interfaces and the device functionalities to the applications in order to create experiences. A bit more later. But we also have seen that coordination of this is necessary, and that's why Qualcomm is a committed member to the Metaverse Standards Forum. I come back to this in a bit. So this is just an overview. So now a busy slide, and I really don't want to go through the details, but you have different components from runtimes to rendering to distribution to 5G networks to cloud operations to applications. And again, this distributes different standards activities across these different domains. Many of these standards organizations are running for a long time. So XR is basically added on top of this, but we still believe they have excellent processes and technologies, based-on technologies. So Kronos with OpenXR, Vulkan, GLTF, MPEG in the compression domain, 3GP, 5G, Wi-Fi in the distribution domains. These are, for example, relevant organizations, as we said. The key issues is to define these workflows and basically identify concrete interop problems where needed. So we solve these concrete interop problems, but this creating these workflows is very important because we have these requirements of power consumption, lowest power consumption, lowest latency, very high quality. And so you really would like to avoid in all of this processing that you add unnecessary steps. For example, you don't want to copy data from the decoding pipeline in the hardware into the CPU domain and bring it back into the GPU. We want that this is a consistent workflow. There is also issues on security decryption that needs to be handled. So creating these workflows, and these workflows expand all the way to the networks where you can basically avoid adding unnecessary latency or unnecessary complexity steps is very important to create these experiences. A few very concrete topics. For example, we have been working 3GP enhancement for reducing the latency and power and be power efficient. There's selected parts here in 3GP radio technologies done in release 15, 16, and 17. Not going into the detail, you can read it when you get the slides. There is also work now in release 18. All of this, again, speak against lower latency, lower power consumption, and higher capacities. And an interesting topic that is starting is basically getting more of issues that is referred to as cross-layer, or basically understanding XR traffic on the radio and optimizing towards this traffic. For example, building schedulers, providing information such that latencies are bounded to stay within the immersive limits. Another topic that we are keen on is basically getting a device reference architecture in place that speaks against what we have today in our products or in the roadmaps. And as I said before, we have runtimes, we have GPUs and presentation engine, we have uplink data, and we have access function that basically speak about the compression of this technology, as well as the delivery of these technologies from and into the device. So we have a work item that is currently ongoing that basically identifies these reference points and defines basically the format interoperability for these places in order to run applications that then can make use of these underlying functionalities using the appropriate APIs and setting up the workflows and pipelines to create these experiences, right? So we as Qualcomm and we at Standards Technology, we are not here to create these experiences. We are here to create platforms that can be used by those creating the applications to optimize their experiences. So that's why making technology accessible through APIs on devices and throughout the networks is a very important topic. Speaking to this, OpenXR is a very prominent standard, probably the first dedicated XR standard, and has gets a significant market traction. So just for simplicity, what does it do? It basically, you have an application running on a device and an XR device with a platform, and it basically abstracts the communication between the device and the application. So from the application, you can push media into the device that then is properly rendered according to the device properties. And it's also basically taking into account anything that relates to head motion or post correction. So basically, it makes sure that the content is properly rendered. And at the same time, you get information from the device that is post controller information, display configuration, form factors, and so on and so on. So that's kind of an abstraction, quite important. Another technology that we see is important is the description of media in the 3D space and interacting with this. And the Kronos Group did some time ago what is referred to as GLTF. And these are functionalities of what GLTF includes, from materials variants, basically mesh compression, 3D objects, integrating this into a scene, creating nodes, allowing interactivity, all the way to doing now avatars, scene graphs, physical based rendering, runtime interactions, and so on and so on. So this is a core standard as well, which we believe is something like the HTML5 for the metaverse, right? And GLTF is a strong candidate to this. There is another candidate that comes out of Pixar USD, but this is more an open source project. GLTF is a real specification. MPIC is doing work in this area to extend GLTF in order to integrate real-time experiences. And for example, getting interactivity is a core issue, anchoring avatar generation, and now more adding immersive videos, dynamic meshes, generally real-time content into scene descriptions is a core issue that we identified needs to happen, in particular also if you have this over the network distributed workflows. So there's clearly MPEG having a big role. The Metaverse Standards Forum was now founded, and not as a new standards organization, but something to coordinate cooperation between standards organization and companies to foster the development of the interoperability standard for an open, inclusive metaverse. So, and it's an invitation to everyone. We founded this in 22. Qualcomm was founding member with only 37 organizations. Within 3 months, this has been grown to close to 2,000 members. I believe we are above this now. And you can look it up and you can join. It's a very lightweight joining, but it's a very active environment. And you would find a diversity of organizations, from platform vendors, hardware, but also going into advocacy and universities. So it's a very open community with a lot of interesting topics. And basically, this organization is basically creating working group projects. And there's a couple of those already established, for example, digital asset management, avatars, but also something more on privacy, security. We have a registration for standards group. So it's getting into action only after 3 months. And Qualcomm is leading some of this work, but we're also very grateful that others and a lot of contributions comes from across the world. This is our view to this. We really want to make the metaverse open. We want to create technologies that are accessible to the community, but at the same time, we want to strongly make sure that we understand these constraints we see, and making the metaverse mobile. Bringing it to mobile is one of the key issues. Well, connecting the real world, power, wireless, and also make it attractive for mass consumers, not just a specific enterprise. I'm wrapping up because I'm short of time. I just want to give a quick hint. What are we doing to enabling the metaverse as Qualcomm Technologies? So we have platforms. You would find Snapdragon platforms. The latest generation is the XR2 that was just published. We do a lot of development on software and algorithms that run on top of the platform to support this. We have reference designs that you can look up on our websites. And we have recently developed an ecosystem and a developer SDK, Snapdragon Spaces, that allows you to get access to platforms, software, and reference designs to build your application on top of this. So get involved. That's a great opportunity to build applications on top of Snapdragon Spaces. This powers reference designs. A couple of those are here and commercial devices. So 60 plus are launched. based on the platforms. And wrapping up, this is Spaces, and we also launched a Snapdragon Metaverse Fund that is accessible with $100 million to actually accelerate the development of applications for the metaverse and XR. So again, you will find this on the web. I skip the video for now, and I just point and summarize what I have said. There's a multitude of technologies coming together. There is connectivity, very important. There's platforms, and we are very committed to contribute and share this with the community. You find data and information here, as I said, and that's about it. Thank you.
Thank you, Thomas, for the very insightful, very informative, I should say, and you've covered a lot of ground. OpenXR, Chronos, MPEG, Metaverse Standards Forum, 3GPP, and some of the work that you do, of course, at Qualcomm, which is also very interesting. There's obviously a lot of ground here, and it'll be interesting, how all this come together, or can they all coexist? Because they're trying to solve different parts of the problem. There is one question. We don't have much time, but I would still like to take this question from the chat. So we have the question on display. So maybe I can quickly read it out. With XR shrinking the boundary between real digital and virtual world, do you foresee in the near future the VR digital headsets and AR glasses replacing the smartphones in our hands and also the TVs in our homes? So
Yes, I think that's an excellent question itself. And maybe not in the near future, but in the future, we see clearly that trend. I mean, even my kids today, they don't use the TV, they use maybe the phone. And it may be that the next generation gets so used to something that is different, that is not in your hands, but it's just on your headset. But what we know is that this needs to be seamless, right? So we'll not wear bulky glasses. So there's a lot of work of integration. But if you remember the first phones, how they look like and compare them to the form factors we have today, there's a lot of evolution possible. And we are basically at the GSM phone factors. Sorry, you might remember the first Nokia phones, how they look like, and put them up. So we are somewhere there, right? But and that will be a technology evolution over the next 20 years. And I think there's a lot of things to come. So not in the near, but in the midterm and the long term, I really see a trend that there will be an ability to have a new platform that replaces the smartphone. Probably not for me, but maybe for the next generation.
Next generation, yeah, I agree. I think it's a real possibility, and we'll have to see how things evolve. But certainly, I think you cannot do these things just with your smartphone. So you need a wearable. You may need other types of peripheral devices. So yeah, it'll be very interesting. So thank you very much, Thomas.
Yeah, thank you
for your time, and once again, a great presentation. So now we move on to the next keynote, Benoit Seber from Nokia Bell Labs. We have a recorded presentation from him, so let's go ahead and play it. Before I just do a quick introduction, so Benoit is a distinguished member of our technical staff at Nokia Bell Labs and is based in Tokyo, Japan. He's been with Nokia for over 20 years, has been a very active standardization lead or delegate in 3GPP. And he also heads a large team in RAN, and is currently the rapporteur of the XR work on the radio side. So I think it can be a good complementary talk to what Thomas presented, which was more on the multimedia and device architectures. So let's play Benoit's presentations, please.
Hello, my name is Benoit Sebir. I work for Nokia Bell Labs, and today I will be talking about the support of XR services in 3GPP as a rapporteur of the study item, so not only as a Nokia employee. I would like to thank the organizers for giving me a chance to talk to you today, and I really would have loved to have this podcast, but unfortunately I had some travel arrangements already planned, and I should be now flying to Europe as you are hearing this. So, my presentation will be organized around three main aspects. So first of all, we will review what XR services are, what kind of requirements they introduce for the RAN, and why they are very tough to support. Then we will look at the study item that has been agreed in release 18 and that is currently ongoing in 3GPP. And finally, I will draw some conclusions of that study item and what we can expect from it. So first of all, XR is, as you probably know already, is an umbrella term for virtual reality, augmented reality, so AR, VR, mixed reality, MR, and cloud gaming, CG. XR technology will impact many domains and many sectors of the economy. We can distinguish probably three different ones. So enterprises, industrial, and consumer. And to give a few examples, we can think about gaming, entertainment, education, military, retail, emergency response, engineering, marketing, and so on. So really, XR is the next big thing coming. Big cloud players are already deploying XR services, and this is a very important topic in general. But why is it important for the RAN in particular? And to understand that, we need to look at the XR architecture. So because of heat dissipation and power consumption constraints, which limit the processing of a device one can have in his hand or next to its body, XR rendering will take place remotely in the network. And that means that typically the RAN will send in an uplink, what we call pose information, to inform the network where the user is looking at, or control information to inform the network what kind of interaction the user is doing. And based on that information, then rendering will take place, and the RAN will then be responsible for sending the XR scene back in downlink. This introduces tough requirements for the RAN. If we look at the characteristics of XR, we know that the traffic is quasi-periodic and comes in large chunks of data. We know that the size is variable, and that is because it depends not only on the content but also on the movement of the head of the user. So if the user moves his head, of course, we need to regenerate the scene, which increases the bitrate. We know the data rate is very high in downlink, so we're talking about tens of megabits, but also in uplink for AR services. And for XR, we need to be able to transmit multiple streams. The video streams, the audio streams, and also the control data. The requirements this introduces for the RAN are very high data rate in average. So we are considering tens of megabits. If we look at some previous 3GPP studies, the typical bit rates that were considered then were 45 and 30 megabits per second. We have high traffic variability. So as we saw just now, depending on the content, but also on the movement of the head of the user, the bitrate changes a lot. Even though we have a fixed frame rate, so for instance 60 frames per second, which gives a frame every 16.67 milliseconds. So even though this is fixed, we have jitter, especially in the downlink, and that means that the frame does not arrive precisely always at the same time. In previous studies in 3GPP, we have considered a jitter of minus and plus 4 milliseconds. The other requirement is that we have to support time delay. So we have packet delay budget of around 10 milliseconds. and reliability constraints around 1 or 10% depending on the service. And of course we have, as always, to minimize power consumption, not only to extend battery life but also to minimize heat dissipation so that the device doesn't become too hot to hold. So in order to see if these requirements can be met in the RAN, 3GPP has agreed a release 18 study item that you can find in 220285, so that's the description of the study item. It's scheduled for completion in December 2022, so later this year. It addresses 3 main objectives: XR awareness, so how the network can be made aware of XR services and its characteristics. And then the study is also looking at minimizing power consumption, so increasing power saving gains and also maximizing capacity. The outcome of the study will be captured in a TR, and the number is 38835, and I have the pleasure to be responsible for that TR. And that study complements studies done in SA2 and SA4. So if you look actually at the history of what 3GPP has done since release 15, this release 18 study item really is just one of the building block of the work that has been ongoing now for quite a while. So the work started in release 15 and 16 to look at the service requirements, first for VR and then extended the scope to all kinds of XR services. In release 17, the work in SA continued and looked at the 5QI definition, so what kind of quality of service requirements and parameters we need for XR services. And in the RAN, we had a release 17 study item that focused on establishing traffic models and methodology to assess the performance of XR services. Now in release 18, so that is the ongoing release, we have the work continuing in SA and in RAN, both as study items. So in SA to study the architecture enhancements for XR, and in RAN to study the RAN enhancements for XR. And that's the talk of the day. That is what I will be talking about to you today. These two study items are expected to be followed by work items in release 18. So this means that we expect XR services support to be enhanced at the end of release 18. So if we now look at the different objectives of the study item, the first one is the awareness. It is described in the study item as studying the mechanisms that provide more efficient resource allocation and scheduling for XR service characteristics. So the problem, as we saw in the earlier slides, is that the XR frames are large and fragmented in multiple packets. So typically an XR frames is made out of several IP packets. If we consider an MTU of 1500 bytes, tens of IP packets will be sent for one XR frame. But the packet delay budget is for the XR frame, so it's not for an individual IP packet. If we look at the figure here, we have different XR frames here that arrive at a fixed interval, so we do not consider jitter on the figure, and the XR frame is made of several IP packets. First one in blue and last one in red. And as you can see, typically the number of IP packets is different depending on the content of the frame. In order to be aware of how many PDUs are in a frames, RAN will rely on the notions of PDU sets and burst that are being considered in SA2. And by knowing exactly how many PDUs there are in a PDU set, we will be able to treat them as a group, so together. Some capacity studies have shown that by having this application aware, so PDU set aware or burst aware scheduling, we can increase capacity roughly by 30%. For power saving, the objective reads as study XR-specific power saving techniques to accommodate XR services characteristics. There are two main problems here. The first one is that the XR frame period is a non-integer. And this is an issue for DRX setting. So for DRX, we have relied on integer to set the DRX cycle, and this has worked well for voice over IP, for IoT, for EMBB, so no issues there. But this is not working then for XR services for which we have non-integer. If you consider 60 frames per second, so that gives us a frame every 16.67 milliseconds. You have two choices relying on existing mechanism. You can configure DRX cycle of 16 or 70 milliseconds. And in both cases, you will have to reconfigure the DRX cycle to compensate for the gap that will accumulate. So with 16 milliseconds, we will have to reconfigure the DRX cycle every 250 milliseconds. While for 70 milliseconds, we will have to reconfigure the DRX cycle every 500 milliseconds. So the solution there is to have semi-static configuration that can cope with non-integer, and also dynamic realignment if needed. Another issue related to power saving is the jitter I mentioned earlier. And to cope with the jitter, currently the only way is to consider the worst case, but that increases the power consumption. So if you configure the on duration of the DRX cycle according to the worst case or the worst jitter, in most cases you will be awake more than needed because the frame will be on time or not as late or even arrive earlier. The solution here is to have dynamic mechanism to extend the time for which the UE is awake. So we can rely on these WOOS signals that we have introduced in earlier releases. Studies here have shown that we can increase power saving gain by roughly 30%. The last objective of the study item I wanted to talk about is related to capacity, and the study item objective reads as study and identify the XR traffic characteristics, cross metrics, and application layer attributes beneficial for the GNOB to be aware of. So in 3GPP so far we have considered three main issues related to capacity. The first one is related to buffer status reports. So BSR tells the network how much data the UE has in its buffers. We have used exponential distributions now since HSUPA, so that was release 6, I believe. So quite many releases ago. And this has worked well for low data rates services with real-time constraints, so for which the accuracy is very important, and has worked well also for high data rate services which have no real-time constraints, so for which the accuracy is not really important. But this doesn't work well for real-time services with high data rate. And that is why we will introduce new buffer size tables. Another aspect is that we know that when a PDU of PDU set is lost, so remember the PDU set is a group of packets, that IP packets that belong together and typically could represent XR frames. So we know when one of these individual packets is lost, the whole PDU set may be useless, so meaning that the remaining PDUs of that PDU set may be useless. So one enhancement we have considered in 3GPP is the discarding of these useless PDUs to free up resources whenever possible. And finally, the last enhancement we have been looking at so far, the study is still ongoing, is the configuration of the configured grant. So configured grant is the allocation of periodical resources to the UE, so for which we don't need dynamic grants. The configuration relies on integer, same as for DRX, and so for AR services, we have the same problem as I explained earlier as for DRX. And in order to solve that issue, then we need also to take into account this non-integer. Another issue also is that the frame size, the XR frame sizes, they vary a lot, and for AR in opinion, this is also an issue for the config grant. So that will be also one aspect that we are going to look at. So in conclusion, 3GPP has been investigating the support of XR services now for almost 3 releases. RAN and SA study items are ongoing now for release 18, and that will be the last step towards the start of work items that will now specify mechanisms in release 18. Simulations have shown in release 17 that XR can already be supported with 5G release 17, and this is because 5G is, of course, well designed and efficient. But the release 18 studies have also shown that we can improve the support of XR services with all these new mechanisms that release 18 will introduce. And a ballpark estimate will be that with these new enhancements, we can increase power saving gain by 30% and capacity up to 50%. Okay, thank you. I would have loved, of course, to answer your questions, but unfortunately this is not possible today. But yeah, thank you for listening, and I hope it was interesting nonetheless. Thank you. Bye-bye.
Okay. Okay, so let's give a big thanks to Benoit for his good presentation. Uh, as I said, he's not live, uh, but if you have any questions, please send them to us, and we'll get them answered. But essentially, as you saw in the presentation, it was focused more on the 3GPP RAN, where you see some of the similar key issues like saving power, handling capacity, which we heard from other speakers as well. So with that, let's move to the next presenter, next keynote speaker, Dr. Manohar Swaminathan. Uh, so Swaminathan is a senior principal research engineer at Microsoft Research India. He's also the founding co-convener of Center of Accessibility at IIIT Bangalore. He has a PhD in computer science from Brown University and professor at Indian Institute of Science. With that, I will hand over the floor to Manohar. Welcome, and we look forward to your keynote.
Thank you so much. Thanks for the opportunity, and let me quickly share my slide. I should also mention that I've learned quite a bit from our previous speakers, very detailed aspects of the technology, the standards. It's been really educational, so thanks for inviting me. So let me just, I think the screen share, if you can confirm. Yes, there you go. Can you see my screen?
Yes, it's visible. Thank you.
Awesome. Thank you so much. So let me quickly get started, and I'll also keep track of time. I think everybody has very kindly kept to time. Let me try and do that. So I will skip this part about XR, VR, AR. We have heard lots of details, including the technical details, but just that my personal view, I think
5G is so critical for XR, and so we need to be involved in setting global standards which are universally acceptable. And that's why I think this is a very timely event. And so, thanks to TSDSAI for organizing this event. Um, XR, of course, potential everybody has talked about, but the key point is that most XR systems today are inaccessible to most people with disabilities, which is where my focus has been on the last 5 years, looking at technologies for people with disabilities. And all of the promise of XR of enhancing skills, education, employability, healthcare are mostly unavailable to people with disabilities today. And as we increase the competence, sophistication of technologies like 5G and beyond, capabilities of XR will be much, much more. And so the gap between those who can access it and those who cannot is going to be even more. So it's important that we address the accessibility gap right now rather than later. Why accessibility is important? Of course, everybody has talked about it's well known that more than a billion people in the world have some form of disability, and these are more likely to be unemployed than non-disabled people. Children with disabilities are less likely to attend school than non-disabled children. Disability disproportionately affects vulnerable populations: women, older people, and those who are poor, especially broadly what we can call as the global south. The PWDs in the global south have a double whammy. They face barriers in all of these services where XR is going to play a huge role, and that is why it's important. More than this, I think when we talk about people with disabilities, there's a settled perception about us, most of the so-called temporarily able-bodied people, that it is for somebody else, somebody who is in a wheelchair, somebody who is using a white cane. It's not for me. But I think it's important for all of us, privileged enough to be part of this forum and privileged enough to have the means to do something about it, to understand that accessibility is for all of us. Everybody in this forum, everybody in the planet, at some point is going to be a person with disability. There are three kinds of disabilities: temporary, transient, and permanent. And as we get older, and as I get older, I'm even more conscious of this. Everybody who gets old is going to be disabled in many ways. So none of this effort is for somebody else who is other than us. It is for all of us. I want to emphasize this point that it is not something we need to look at as, okay, it's good to have accessibility for all of these groups. It's going to be important that we build in accessibility for us to be benefiting from it as we grow older. And of course, temporary disabilities, transient disabilities are going to be part of everybody's lives. And at that point, we will realize why thinking about accessibility at the foundational layer is so important. So this is important takeaway that I want all of us in this group to go with, that it is for us. Each one of us has to be looking at how can I make whatever technology I'm building accessible to a much wider population than it is today. Having said that, I also want to look at an alternate view which is promoted by this International Classification of Functioning, Disability and Health, more widely known as the ICF, which is an international standard described, adopted by WHO and about 190 plus member states. It essentially systematically codes all aspects of human functioning, takes environmental and societal factors into consideration. It's value neutral and an objective standard. As a bottom line, you can think about every human has a range of capabilities across physical, mental, and cognitive layers. And each of us has a certain spectrum of certain capability in each of these dimensions. And when we are trying to perform a particular action, there is a gap between the performance that we are able to do and our inherent capability. Accessibility is the bridge that bridges the inherent capability I have and the performance I'm able to output because of many, many factors around me. So it doesn't talk about, oh, somebody has lost sight or somebody cannot walk. It is not about us, different difficult physical disabilities and so on. It is about this person, if we provide the right environment and enabling technologies and society around, how much more this person can be capable of performing various actions. So this is a standard that needs to be made aware widely. And when we are talking about assistive technology and accessibility, this is something that needs to be taken into account. So let me then just talk about a human capability spectrum. What we need is that when I get into an immersive environment, all I need to have done is create, let's say, a file, if you will, a metadata about what are my capabilities across all dimensions of physical, mental, and cognitive. Assimple thing is my vision, left eye, right eye. Do I have full sight here, full sight there? If not, what is my power? What is my astigmatism? What is my long sight, short sight? So if I set this once, whenever I go into any environment, the visual system adjusts to my capability rather than me having to set up, go into settings and say change this, change this, change this to match me. All I need to do is for entire set of capabilities for me, I enter in a standard form each of this. And this is available whenever I log into an XR system. This is available magically. The system around me configures itself so that if, for example, again, just using the visual example, if I am colorblind, all the colors there in this visual field are adjusted for maximum visibility to me. I don't have to say, oh, I'm colorblind, I can do green better than blue, etc. I say it once and the system absorbs it and delivers a experience that matches my capability. This is really the underlying message that I want to convey, and this requires a lot of effort across all the stakeholders. Just an example, in 99 we set up the web content accessibility guidelines. A simple example is images. Every image on the web should have an alternate textual description so that anyone with vision impairment will have an understanding of what this image is there. For a video, of course, again, this standard is evolved audio descriptions. So if you have seen Netflix movies or Amazon Prime movies, you select audio description of a movie, you will get most of the experiences, even though you may not have sight. What we need are standards for XR across all human capabilities, not just vision, which is really a very, very large scale effort that needs to be taken up. I will just give one example from our personal, my research effort at Microsoft Research. This is to make video games accessible, immersive video games accessible to people with vision impairments. So we used what is called spatial audio as an alternate pathway for conveying the information about the rich visual field around you. And I won't go into too much detail. Spatial audio, let me try and play this. This is a immersive first person game, shooting game or whatever adventure game. And if a person with vision impairments were to play this game, how can I enhance the experience to make it accessible? Just I hope you can hear the audio, right?
I don't get the audio, sir. We can see the video well, but
Okay. No, I think let's not. I'll just try and describe it, right? So, spatial audio means you know where objects are located. So, every object in the scene of importance, every scene perspective is described in spatial audio. And if I want to reach the word in the picture, there is a spatialized audio beacon that is emitting beep, beep, beep. And using that, I can move around and I will know what objects are there along the path. I can pick it up, I can go, etc. So this is something which will allow, just like a movie with audio description, somebody can actually play these immersive games with this kind of extended spatial audio description. That's good enough for this talk. Um, so let me just move. So this requires, this is a key thing, every object, every scene requires an audio description, as it were. And depending on where the user is and what intent the user has, the appropriate information about the world around has to be played out in spatial audio. Again, This requires, if you extend it beyond the visual capability across all aspects of human capabilities, vision, mobility, hearing, dexterity, reach of hands, grasp with fingers. Is there a 5 finger hand or there are no fingers? How would I use an interface if I don't have fingers? I don't have to buy an extra device to do it. I just say I have one hand with no fingers, other hand with 5 fingers, and if a game requires a right hand to have multiple fingers, it has to give me an alternate interface smoothly without me having to invest in hardware and software. This is really the goal, and for which the objects in the scene have to have metadata, and these metadata has to be standardized and be available to all the platform providers. Have to agree on both the capability standards, which is what Professor Pilar mentioned as the cup. Professor Pradipta Biswas is heavily involved in this. This is common user profile. This requires a spectrum of standard description of all the human capabilities on one hand, metadata of all the engines, objects in the world on the other side. These two should meet for a very automatic magical experience of anyone with a range of capabilities. I just stole a slide from Thomas's talk. You can see that there are so many organizations involved in standardizing very many aspects of this. The key thing that is still missing in my view is this unified view of an experience across various capabilities, which is really the point I wanted to make. So I will stop here and thank again for people for giving me this opportunity. I think I have some more time, but I would allow for questions.
Thank you very much, Manohar. I think it was an excellent perspective. We often don't start with accessibility when we define standards, but I think, as you rightly explained, it's an important subject. So we have one question, I believe. Can you flash the question, Asif? Or maybe I can just read it out. So it
Please,
says,
please.
it's from Dr. Bhupender Kumar from Indian Institute.
Mhm.
One of the triple I's. I don't have the full information, but I want to
Okay.
get I want to get
Sure.
I want to get enlightenment about how XR platform calibrate itself with Deuteronomy red green. So how does, I guess,
Oh, I see, I see. Yeah, yeah. So the
self
color is referring to color perception, right? So I was mentioning my wish, in fact, aspiration for how your VR XR systems should be configured, right? So you're probably familiar with the color spectrum and the color blindness and so on. There are standard ways of describing color vision of humans, right? Now I need that to be part of my personal capability specification, saying, okay, my left eye has this color spectrum vision, right eye has this spectrum vision. And there are also lots of history of research into, for people with a certain deficiency in color perception, which colors make it differentiated. Essentially, you want colors not to merge with each other, indistinguishable from each other, right? So there is lots of work, nothing new. There is physiological work on distinguishing color perception for people with various ranges of color impairment, and how to specify that also exists. We need to bring this together and say, if the person has this range of color perception, all the color descriptions of objects that are going to be visible need to be modulated with a filter which will change red into yellow. I don't know the colors, so you will just apply this filter uniformly all the time, so this person doesn't have to struggle. Or alternately, the designer of the experience need not have to look ahead and say, how am I going to make it accessible to this person's color combination? That's too much for a game designer or an object designer. So that's the fundamental problem. If you want accessibility to be done by either the world designer or the game designer, that's, they're already struggling to make their games and sell their games. You tell them, okay, you make accessibility for everybody on the planet. That's not what is going to happen. That role has to be taken by large entities, the platform builders, the Microsofts, the Metas. These are and Qualcomms and Nokias and all of those large multinational players across the value chain of hardware, software, and platforms. These are the people, the groups which have to stand up and say, I will make it easy for individual content creators to make accessibility part of their work instead of asking them to spend 20% more time to create every experience. That's fundamentally the point. Thank you very much for the question.
Yeah, thank you. Thank you very much again. So there's one more question, but I guess it's an extension to the previous question. Maybe you can try to answer on the chat in the interest of time.
Sure,
Um,
sure.
yeah, I just wanted to highlight that, I mean, some of the gaps that you mentioned in terms of standards, I think it's good that you bring that up. And of course, TSGSI is also a platform where some of this can be discussed. And we also have, I believe, an ongoing study looking at some use cases for XR, probably that can be contributed for
Uh,
further discussions.
so just to add to that, right, I'm glad that TSDSA is looking at this because 80% of the people with disabilities live in the global south. India is home to a huge number of people with disabilities across the spectrum. But India is not the originator of some of the key technologies. And unless we are going to be consumers, large consumers, but we are not on the table of setting the standards. And so
Right.
it is us, TSDSI, should put the effort to say, look, a majority of our population will need the standards and let us put that early on rather than maybe later after we get the
Correct.
first thing done.
Correct. I think
That's really why I'm so glad that TSDSA is taking up this initiative. Thank you so much.
excellent, excellent. I think very good point, and we'll make note of that. So thank you very much again, and I believe now we can switch. So that concludes all our keynotes, and we have to do the panel discussion. And I please stay tuned because we will have some interesting discussion around on many of the subjects. Uh, so the panel, Chandrakanta, would you show the panelist slide if you can? Perfect. Yeah, so we are about 10 minutes behind schedule. It's not too bad. Uh, we may try to catch up a little bit as we go. And the panel discussion is scheduled for 45 minutes. And we have four panelists today. We're going to discuss, we've titled it Opportunities and Challenges in the Real World of XR. We have Professor Pillar and Thomas from our keynote lineup, and in addition to them, we have Dr. Girish Pujar, who's working with National Remote Sensing Center in ISRO, which is our space research agency. And welcome, Dr. Girish. Your insights would be very helpful to the panel. And also,
Thank
we
you.
are accompanied by Dr. Bignaraj, who's a senior research scientist at Nokia Standards. Uh, and he has a lot of experience in wireless and next generation networks. So his perspectives would also be very valuable in the panel discussion. So we have four panelists here. So welcome, uh, Professor Pillar, Thomas, Dr. Pujar, and Dr. Bignaraj. Uh, I believe we can get started with some questions. So I have the way I want to run this is, I have a few questions prepared, and I will go through questions, direct them to specific participants of the panel. But I would like to start with this first question, which is sort of a very generic question. It might have already been covered in the panel, in the keynotes, but uh, we've in this whole session, we have learned, what XR is, a little bit of what metaverse is. Uh, I don't know if there's like a real proper definition of metaverse, but let me ask this very generic question. I mean, I would ask each panelist to give their reflections um, in 1 to 2 minutes. So, what is exactly new? Let's say, if we're talking metaverse, like we're already talking XR. So, what is new with metaverse, and what are some of the advantages over traditional media? What are some pros and cons? Because it's there's a lot of things that we can do, but there may be things that we will stop doing, because of metaverse. So just maybe a generic reflection on this question. Once again, what is new? What are some advantages over traditional media, and the implications? So let's start with Professor Pillar.
Um, uh, this is a very good question. What is new is that the possibility of meeting, and to me, what it is very new is the engagement. The engagement on XR compared to 2D or with traditional media is completely different, and that we know. Now, how we meet, to me, that is a challenge. How do I choose you and I trust my trust in you? That is to me the biggest challenge.
Thank you, Pillar. And let's go to Thomas.
Yeah, I agree that the engagement is basically this is what new. So you basically no longer have a lean back experience as we have consumed media for a long time. Uh, People who did gaming are probably more familiar for a long time because that's where you interact. But now you have this combination of integrating the real world. So that is probably something that was not part of the gaming with all the AR opportunities. Also adding enterprise, adding conversational. So that's kind of the experience that is new, right? But we need to bring this experience into something that is easily observable by users without being hampered by devices or technologies that are not good. So either they are uncomfortable or they are just not giving you the experience. So that's the technical challenges. And I think the next step of a technical challenge is, which I'm always discussing when I see this great edge compute, and is how can we scale this, right? How can we bring this to the mass consumer? That's going to be a massive challenge because you can do a lot of lab demos, but when you bring this out, there's a lot of questions on scaling this to mass users. That's what we want to do, and I believe this is where we need to do a lot of work and understanding, and maybe also to step backwards to say that not all the experience will scale in large across the globe to everyone. But maybe we have a bit more discussion on that one when we move forward.
Makes sense. Thanks, Thomas. Let's go to Dr. Pujar. Your take on
Yeah,
this question.
thank you. And for me, it's definitely a aha moment because I, being from a perspective of Earth observation, it's a very different experience for me. And my response to this question stems from my learning and experiences, especially as on today, we stand on the moment of COP27 declaring that early warning for all. As Manohar sir said just now, that people are ailing now, Earth is ailing. So for me, this XR actually provides an opportunity to put entire things into a third dimensionality, wherein all our languages have evolved. Because when we speak anything, it's all evolved in third dimension. So XR gives us a scope wherein you can put every scientific information into the perspective of a commoner, and he can actually interact with whatever we call as objects, entities around him in a sense of empathy, and get ready for that kind of events or extremes that are coming out of climate change. That's one side. And on the other side, like as Thomas said and Pilar said, the third dimensionality is again very important because the Earth observation, when you watch Earth from space, it's mostly two dimension. Now we are entering into an era of three-dimensional remote sensing, and it'll go more. So in that context, and this moment of being hyper local, because it has to be customized to the users at the final stage, at the base of the pyramid. So there, XR plays a very powerful role for me. Thank you.
Thank you, Dr. Pujar. And then we go to Bignaraj. Uh,
Uh,
yes.
okay, thanks, Suresh. So I'll put it in three perspectives. So we started from, if you remember, from text, then we moved to mobile, mobile calls, then video calls. Now we want more. So we are expecting that we in future will have more 3D calls, so that with our peers we can directly have interface in the 3D environment. So that is one aspect we are going towards metaverse. Second thing, from as Sabir also talked about, from 3GPP point of view, also from the way we started, like AR, VR, then XR, the more was towards gaming kind of applications. But now with metaverse, what we are looking at is it could be, the metaverse could be of a combination of many metaverses, or combination of many virtual worlds, and each virtual world would be stationing at some place, and digital twin of that metaverse is collated at one place, where avatars also from different places will also get collated, and all this information is actually a lot many video or data and haptic kind of data is transmitting from one place to another place in real time. So that also is an extension of into the metaverse world. Then one more thing is, in the video game or immersive things, currently we are kind of indoor space, but now we want to go outdoor, more ubiquitous kind of accessibility of this metaverse applications. So I think these are the newer things with metaverse we are looking at.
Thank you, Bigneraj. I think that's good. So we're saying there's a lot of interesting things that we can do, but it's also complex in a way. So I think we try to figure this out as we go. So let me go on to my next question. This is more related to a bit of standards, but also, we have heard specific talks, for example, from Professor Pillar and Manohar on accessibility as a central piece. So this question I want to ask particularly to maybe Qualcomm Thomas and also Professor Pillar, following that, is standards community actually looking at accessibility as one of the key requirements? Uh, is that being considered? So maybe we start with Thomas, and if not, then how can we actually make this mainstream?
Okay, I believe that's a good question. I have been following this a bit, and it's generally coming up as something we look into, not as the first priority. But okay, let's do step by step. I believe there's a question of technologies first, right? So technologies for hardware interfaces. So then there is questions of interconnection interfaces, and then there is the application space. And I believe accessibility is predominantly an application service. Once in a while, accessibility is also a question around regulatory requirements and so on and so on. So now bringing accessibility into an application is probably something we see it's possible, and we saw some great demos, right? So it needs to be brought probably more to the service community, but obviously there needs to then be components that need to be made available. We also see a question in the chat that relates not only to accessibility. There are aspects that are not really a standards questions, like but standards can only be partially supporting this. So identities, trust environments, basically. So the whole social aspect. So the interconnecting the virtual world, where you basically have different means to interconnect and to also create an environment that is accessible for everyone, but has privacy, security. So all these questions come into play, and they're considered. But we need people to generate the requirements, but also then execute against these issues in creating the technologies. Now, specifics like subtitles are obviously part of the media experiences, right? Then there's questions automatically generating subtitles, right? So AI gives you a lot of abilities to automatically do this type of things. So I don't believe it's ignored, but it needs to be always brought up. And I think it needs to be also done through not only standards, but also through clear requirements that are done through regulatory constraints or whatever people believe is the right environment. I cannot speak to this, but I believe you have experts on that.
Yeah. So I hear maybe I think Thomas, to summarize, is you're saying it's a stepwise approach. It's not off the table, but probably we are at the initial step and not there to cover.
Yeah, but what I'm saying is the technologies are available, right? From you can make it happen, but it's something where it needs to be executed throughout the service community to use the technology and bring it forward.
Okay. So let's hear from Professor Pillar, if you share the view or you have a different
Uh,
view.
of course, I share. Yes, I agree completely with Thomas. There are, and I agree that it is at the end user spectrum. It is at the user end. Yes, I agree to that. But I think there is also some items, for example, when we have to put sign language, that is an image, that is a video. So we have a picture-in-picture situation, and then MPEG has something to do there. So it is not only to do with the end user. I think it's only to do with the general architecture that has to take into consideration accessibility. The problem that we have learned from uh, going from analog to digital and from digital to is that accessibility is always thought right at the end. It is like an orthopedic issue, and then it's expensive and it doesn't work very well. So if we thought about it at the beginning, like in the metaverse or in the mediaverse or in the XR, if we think about accessibility when we are defining the architecture and when we are defining a workflow, then it's less disturbing later on to add it, to think about that. So to me, it's just one more item, one more requirement that should be taken into consideration right at the beginning in the architecture. Sorry,
Yeah.
Thomas.
No, and I think it's it's to me it seems like more like a horizontal thing, right? So any system we design, we think security is important, right? And without security being there, the product doesn't get launched, for example. So
Yeah.
similarly, maybe accessibility is probably not considered as serious as security, but uh, I think with metaverse type of platform, accessibility, I guess, becomes a bit more important than a normal 2D, kind of viewing experience.
I think also what Manohar was saying is that it is true. This new uh, this new environment allows for house-ridden people, for example, to enter or to get out from their houses. So we are offering an amazing possibilities to people who have disabilities, and disabilities are enormous. So it is a shame that we don't include this and we don't have this, we keep this in mind from the very beginning, because the possibilities, I know that there are many problems, but the possibilities are endless, and it may change the life and the work of many, 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 many people. So I think it's worth considering it.
Okay, point well taken. So thank you. So let's move on. So this I want to switch a little bit gears here. Try to understand. More from the Indian context, because often one of the things in TSDSI we try to kind of brainstorm or put more focus is uh, what is it so different in an Indian context. And so my question is, so are there any fundamental use cases that we see from an Indian context, or certain requirements that come from the users here, that maybe can be brought out from this discussion, or in general. So I'd like to pose this question to Nokia, because I'm told Nokia is leading one of the studies on metaverse at TSDSI, and but also then go to Dr. Girish to follow up, particularly because you're working with Indian Space Research, and probably something from the remote sensing perspective that you briefly mentioned. So let's start with Bigna.
Yeah, this is a very important aspect from Indian point of view. What specific use cases that we think that XR and this immersive kind of applications can bring. So, in my view or our view, that from Indian or such country which are developing, there is a gap between the rural and the urban people. So to say, for example, we can take the education system. So the rural people are deprived of many facilities that urban students are getting. So with the advancement of these immersive applications, we can bridge that gap between the rural and urban, so that the students, the school students and college students can get the similar kind of immersive study environment that a good school or college in urban area students are getting. So even it is a the same kind of things also can be extended to the healthcare system also. Like we have a very basic type of healthcare in the gram panchayats and so on, so that even the specialty doctors in urban, they are not ready to go to the rural places, so that we can bridge that gap and create with just a good connectivity and some VR headsets and something like those immersive experience. We can bridge those gaps and create that ecosystem, extend it to the rural part of India. And something also from the agricultural point of view, and governance and welfare schemes. Now we don't know, the governance is not aware whether the schemes that are floated is actually consumed by the end users in the rural area or not. So with this more immersive kind of village metaverse, even PM can visit a village metaverse and see whether the schemes that are floated is actually carried out in real or not. So a lot of these kind of use cases that we see has a lot of potential that can be used by use of this metaverse kind of use cases.
Right. Thanks, Bigna. I think you bring out some really specific aspects in the context of India, and I guess cost is a is a big factor also here. Is
Of
you know
course.
we tend to be very cost conscious given the the purchasing parity that we have. But then we go on to Dr. Girish. Do you have anything to add on India specific use cases?
Yeah, yeah, that's a very nice opportunity for me where I can bit a pitch in and give a bit an extended deliberation. Actually, Thomas had showed a very nice slide. He had shown one slide. Am I audible?
Yes, yes, we can hear you,
Am I
Dr.
audible?
Girish. Yes, we can hear you. At least I can hear you. Yeah.
Yes, yes.
Yeah. See, of course, here I can have a bit of more of than deliberation. One of the key answer for this was in Thomas' slide. Thomas showed one slide with a circularity. In one part there was geospatial and many other data sets coming into the entire data structure in XR. And being a person handling Geo Manrega, which is the government of India's biggest initiative of applying spatial technology for rural development and monitoring watersheds, it put me a very uh, mm, a ripe and fertile ground to develop applications at different scales of application. Because just now, as Vigneshwar Panigrahi said, that we need a village metaverse. Yes, I need a village metaverse. That's one of the biggest requirement. Plus, as I just quoted, since the climate change is going to put us in a very vulnerable situation, we need to be forewarned about storms, then heat waves, floods, droughts. These are going to be impending endangerment for the rural economy. And agriculture, it's going to lose a lot, like 4 to 9% is a deceleration of the agricultural productivity because of all the climate changes. So if these entities can be conveyed to semi-literate and illiterate masses in a non-English interface, because most of our content, it speaks to ourselves. One of the skill secretary said, I remember from one of the seminar, that most of the government websites speak to themselves. So the ease of language, the ease of communication that comes naturally with the XR, and especially the compassionate minds that are sitting in XR, like they are trying to delve deep into disability. So they will definitely make XR technologies very amenable for semi-literate and illiterates, in a sense that it directly conveys the content to them in graphic manner or some kind of symbol, etc. So that gives us a great advantage of building use cases in that term. And finally, quoting one typical set of success stories that are prevalent in India, especially in rural economy, uh, with respect to watershed conservation and doubling, tripling, and even up to 5 times the rural incomes have been increased. So there's a need to bring those use cases to others for them to emulate, and especially when we use technology like XR, like what Thomas demonstrated as the wearable devices. Those things can take total spectrum of technology, like what we are doing as a WebGIS technologies. That entire GIS can become a ARGIS, augmented reality GIS, and go and sit onto the uh, headsets which can be given to set of villagers and train them, given exposure, and make them partners in progress. So this kind of the LIFE, what Prime Minister is quoting, and the target of leaving no one behind can be very much near, can be very much possible. And as a final quote, it's a 50 cent that's required at a global level to enable that early warning for all. There, I feel a greater role of XR. So that's what the overall use case for me. Thank you.
Thank you, Dr. Girish. A very interesting perspective on leaving no one behind with XR. I think it's a very good
Yeah, that's
probably caption that we can use. Um, so let's go to the next question. Um, yeah, I think we talked about some of the device types, and we also talked, are we still going to use smartphones? But I think we also covered in the keynotes a lot of challenges with these kind of XR types of devices, because they are very resource constrained, right? So we need to think of the compute that's available, the battery life, the heat dissipation, all these aspects have been brought up. And how can we actually overcome these challenges without compromising on the capabilities of XR? So I'd like to hear from, so let's say Thomas, and then we go to Pillar. Thomas?
Yeah, I mean that's kind of what we're doing, right? So we're doing with daily research on understanding better what we can do, and there's multiple factors. Again, I mean, probably it's similar to what we have been in the development with smartphones, who have been more and more powerful, more and more integrated. But also, I mean, the dimensions of power saving, power consumption is not only an issue for what we talk about climate change and decarbonization. It's a matter of much more operational issues, basically, to make it work. So again, I believe it's something which is part of our DNA as Qualcomm doing research of making this happen. What are we doing with this? Well, there is improvements in integration, right? So we are now at 4 nanometer technology, so maybe we go down. That will help. There will be um, new functionalities, new hardware, new display technologies, making the glasses lighter, new battery enhancements, new connectivity abilities. So there's a lot of small pieces that continuously will improve the technology, and a lot of people are working on this one. Obviously, to drive this development, this is a huge amount of investment of R&D. So basically, we need to create at the same time business, and business is created by applications being built on top of this. So that's where all of the communities comes into play, right? So we need to open up the technologies that many people can build applications on top of this, and that's where I believe the openness and the applications on top of this that make these technologies accessible. And you need not to have a computer science PhD with 20 years experience to build an application. So we need to make it simple, right? So we need to abstract the problem so that people can build what they're used to and not having to go into the detailed hardware drivers and so on and so on. So all of this basically needs to happen. And the last point I really wanted to make, I believe an important topic where Qualcomm has committed to is to keep the technology open. And a very good idea is to like have it like the internet. It's an open platform where you have open APIs. Everybody can contribute and consume. Um, and we want that the XR and the metaverse in this context is open to the world, because it's obviously always structured that larger ecosystems verticalize these experiences and benefit maybe from the deeper integration. But it's a continuous effort to make sure to keep it open for and open and then global is also a very important issue. We don't want to have technology silos being done in India, in China, and US. So keeping it global, I think that's also very important. And that all of this will help economy of scale, of better integration, right? So that will help us to create products that are then more and more integrated and address these challenges. But it's a matter of time, but also a lot of R&D needs to go into this. Yeah.
Right. Yeah, makes sense. So let's hear from Professor Pillar as well.
I agree completely with Thomas. Open, it has to be an open technology, an open environment, for sure. The other thing is that I think the technologies are there, and I think the integration is the next stage. But also, I think we need a lot of artificial intelligence, to widen the models that we have at the moment. At the moment, the models that we have for interaction, for example, are basically gathering the data which is mainstreamed. I think now, because of people with disabilities, if we want to integrate them, we have to also get the disassociated data that is never considered because it is an extreme. So it is now that we understand and we have a quite good know-how to widen up this spectrum to include this data. And that would allow for people with disabilities to communicate, to give orders, because the speech to text, for example, it would be understood. At the moment, it's not understanding unless you have a really good accent and a really good speech. Nothing works. So I think, but the technology to me is there. And it is very important to build, to have it exactly what Thomas said, to have it open, to build, to allow for people to develop it further, to build on top of it, and as usual, to have accessibility in mind from the beginning. Sorry to be such a pain, but it is my role here. So yeah.
Right. No, I think it's a very valid point. So it's always like, there has to be this kind of we work in a loop. So you start to build things, you get feedback, you refine them, and over a few years, we have the right product that meets all the challenges. So maybe next I want to ask Nokia, in terms of, when we talk XR, there's a lot of KPIs, right? So we talk, the amount of bandwidth that's necessary, the capacity, and the set of media requirements. And is this something that 5G or 5G Advance already addresses, or is this uh, we're only kind of addressing part of the problem, but the 6G is probably the big thing to handle all these KPIs and requirements. So what's your view on uh, how you see XR or metaverse in terms of,
Yes.
yeah, what is the right phase or standard? Yeah.
Again, a good question. So, as Benoit also addressed, that we started from release 16 onwards on various type of VR applications. But as and when the application is getting matured, the level of data that it requires to be flown from one place to another place, from the virtual, the real headset to the virtual server wherever it is, and so on. So that gets more and more data flowing, and there is also with XR and metaverse, it's multimodal data, and there has to be a synchronization between these data. So there are these basic KPIs which get evolved with each release. Like release 17 had some VR type of applications were in mind, like cloud gaming or VR immersiveness and so on. So for that, they define 5 to 10 millisecond latency, then 99.99% of reliability, and some throughput of tens of Mbps. But then with release 18, we see a lot of more adaptation of or enhancement of these applications into multiple various other domains, like industrial use cases, enterprise use cases, and so on. So that bring a lot or enhancement in the KPIs. So these will keep evolving, like as I was mentioning with metaverse in release 19, what we are saying that the digital twins of a whole space, for example, and the tables, chairs that is there, or it could be a like a Taj Mahal's metaverse. So all the physical places, digital twins has to be transferred from one place to another place. So that may bring lot much enhancement in the KPIs, basic KPIs. Then apart from the basic KPIs, there are also KPIs, for example, user satisfaction levels, that how many users have 99% of frame got successfully received within that time bound that is there. So these will be the derived KPIs that can define further release 19 and maybe 60 metaverse type of applications. Yeah.
Yeah, thank you, Niraj. Yeah, I think yeah, as you said, I share your opinion that I think the KPIs will also be evolving, and standards also need to evolve alongside. And given the scale of the work and potential use cases, I think it's a multi-year effort. So good. So then maybe I have one final question to all the panelists, and we can conclude after that. I'm looking at my clock as well.
Just 1 second. I had one small
Yeah,
submission. Suresh,
that's
I
true.
had one small
Yes, go,
submission.
yeah, please go ahead. Please go ahead.
See, since we come, we have a lot of issues we face a lot of issues in geotagging because Manrega, Minister of Rural Development wanted to geotag all the assets that are created in the villages across India. Okay, so when you talk of standards to serve a kind of metaverse kind of content to remote areas of India, as a standards institute, can you set up some geographic envelopes like extremely remote areas will have a low resolution metaverses delivered, whereas the or central areas or the urban areas you can take it from the queue of nighttime light images, because nighttime light images provide actual reflection of the economy. So where the economy is strong and your signals are strong, you can deliver a very dense metaverse, whereas in the remote areas, even if you deliver a low density metaverse, still it will serve the purpose of information. So this is my submission. Thank you.
Yeah, thank you very much, Krish. So people, looking into standards, please take this as a requirement. Low resolution and high resolution metaverse.
Yeah, it's been a big issue. When you go to forests and villages, it's very difficult.
Correct.
And there's
You may not need
deforested.
that
So
very sophisticated high resolution.
yeah, but information is important.
Yes.
Definition not be that fashionable.
Yeah.
It can be
Right.
bare.
Okay. Good. So yeah, my final question is, I think while metaverse, is very exciting, and there's a lot of possibilities. I think we need to keep in mind some of the social and behavioral impacts of using XR. Uh, I think this is also very important because technology sometimes is good. It's disruptive, but in terms of social and behavioral aspects, also it has a possibly a negative impact as well. So how do you see this? Do you agree with this issue? And is there something we need to do, or how do you? I would like to hear from the panelists on this particular topic. So let's start with Thomas, and then Pillar, and then the other panelists. So Thomas.
Well, I mean, okay, so a consciousness of the technologies we are bringing to people and how they can be used, I think, is always very important, right? Um, so at the same time, I believe there is different responsibilities. Like in our company, obviously, have people who very carefully look at what are the impacts of technologies. How can we make sure the whole issue around AI, machine learning? What are the social, what are all the impacts we're having? And typically, issue around AR is you continuously running sensors on your device. You're tracking your environment. There's a lot of issues around privacy ensuring, right? So we as Qualcomm, we are also very much wanting to focus that certain processing needs to be happening on the device, because there's a scare of moving all data to the network. So there needs to be a pre-processing of things being done. So there is obviously aspects that speak to issues like trust, authenticate yourself, digital twins, so fake aspects being produced. So, and I believe the first thing is to have the awareness of this also in education. So that needs to be brought up front, that we just get aware of the potential threats. I never believe we should stop technologies for the purpose of not doing it, but the awareness is a matter of um, the the community to basically being educating on these issues, and making sure that the services comply to rules such as privacy, accessibility, and so on and so on. So awareness is very important, but let's not stop the technology for the purpose of these potential threats. We need to create the means to resolve this.
Mhm.
And there's efforts obviously in this, but invite people continuously to discuss these issues.
Right.
To wrap up, the Metaverse Standards Forum, for example, has a specific group where people are invited to join this, because maybe that gives them a common voice towards a broader environment. Right? Thank you.
Very good. So thanks, Thomas. Let's hear from Professor Pillar on this issue.
I fully agree with Thomas. I think we should not stop technology. That would be terrible. And I think we can't stop people from behaving bad, because it's part of human nature. And to me, the only solution is awareness and education. Only through education we will be able to make people understand what the technologies can do, cannot do, how they should behave. A part of the problems that we have today is because people are not aware of what they should do and they shouldn't do, regardless of the people, the other people, or the other systems that they want to get from you, whatever. But I think if we were more aware, then the reduction on the challenges would be massive. Yeah, and yes, I mean what Thomas said, I think it replies everything. Yeah, I agree.
Okay, excellent. So uh, yeah, then let's hear from Bignaraj next.
Yeah,
Bignaraj.
I sort of believe that we have to look for the younger generation who in this next generation kids, they are very much into this mobile world already, internet and mobile and so on. So with this more immersive kind of applications, how do we make sure that they may not indulge in something which they should not? How do we make sure that they utilize this newer technologies to their best benefit, not for the worsening their lifestyle and so on. So that is one part of it. And second one, it's very difficult to get out of the metaverse if you get into the immersive space. So how do you make sure that the perception of time and space how do you make sure that you have that control in your hand, and how do you practice that thing? So that is also an important aspect going forward, I believe.
Yeah, thank you, Bigneraj. Very valid points, and I completely share with what you said. And then let's hear from Dr. Girish, your perspective
Yeah,
on the impacts.
yeah. I was yesterday. Yeah. It's a very soft site. Of course, I through my internet when I was going to browsing through some sites, I found one website which quoted the XR solution for all the SDGs. We have 17 SDGs for all the sustainable development goals. He has quoted some kind of adaptive approach so that the entire sustainable development goal for society, they will be addressed. And on one more instance I found was in a United Nations conference, the UN has created a UN VR, and it seems they showed some critical movies about some war-torn country Syria or something to some heads of the states and heads of the institution. The entire pledging of the funding they meant for the particular initiative went up 3 times. So one set of VR movie made entire difference to the decision makers because it made them to get into the layers of empathy. So that feeling of being immersed probably brings a behavioral change in any of the person who is willing to use XR on the positive side. Other negative side, as Pilar said, and other people say that you cannot stop technology for the worst part of it. But essentially, when we are moving towards this kind of inclusive approach, definitely XR will give anybody who is on the fringe of the development a sense of esteem, because when he's part of a technological immersion, he will definitely have a sense of esteem. I got a very good experience. Just to tell in Indian language, हमको एक अच्छा चीज देखने के नहीं मिला. Sorry to Thomas. So that sense of esteem will definitely go up when somebody is exposed to an XR. The moment in a routine, as a middle class person, when we go regularly to airport, definitely more order comes to your behavior because you see a lot of ordered things. So in XR, when you see a lot of ordered things, which will come in sequence, which will come in a proper dimensionality and the way you want it to be, so definitely the people will get into more an orderly thought, I feel. So especially those who are shy of coming towards a discussion may get innovative cues, and they may actually contribute to the overall creativity of either rural development or a semi-urban development, etc. Finally, when it comes to disasters, when you train people to handle disasters in virtual world, definitely all of their skills of handling evacuation, escaping a forest fire will definitely go up, and their behavior will be definitely at a delta X level than the earlier level. So that's my feeling. Thank you.
Excellent. So very good points, Dr. Girish. And yeah, I think like with all technologies, it does benefit and make things more efficient. And if you use it the right way, there's obviously more good than harm. So that's excellent.
Yeah.
So that concludes the questions that I had prepared, and I think we're also running a little bit over time. So it's time to I think wrap up the panel session. So thanks again very much to all the panelists for taking the time out and participating in this very interactive panel discussion. I don't know if Professor Pradipta is on the call because he
Yes,
has other engagements.
I still am.
Oh, you are okay. So please, Professor Pradipta, over to you to conclude the session.
Thank you. I am audible, right?
Yes, yes, yes. I can hear you.
Yeah. Thank you. Thank. It's a fantastic session, and we think different applications, points of view, and future applications. So, if I quickly summarize that, we start with flashing some applications at IISc. I started with that, and then Professor Pilar shared his research outcome in terms of this 360-degree subtitling, and I am sure that it will be pretty useful for Indian context also. That as me and Dr. Agarwal from DOT, we are trying to propose new draft recommendation or report at IQ on captions for Indian language. Next, Thomas, he kind of, I can tell, spoke the mind of all XR developers that whatever we develop applications, this latency, resolution, heating up, everything are some existing bottleneck which stop us from taking laboratory products to actual users. And I'm very happy about this in the Qualcomm effort on the Snapdragon metaverse. Definitely, I will tell my developers also to explore that. And then we have this recorded session from the colleague from Nokia, and we looked at the RAN and 3GPP connection with metaverse. And finally, we have the presentation from Dr. Shami Manohar. So he is one of our former faculty who started this faculty entrepreneurship program, and he gave a fantastic holistic picture of addressing the need of disabilities with a case study of using metaverse for visually impaired persons. Next, in the panel discussion, we looked at future applications. So Dr. Girish from ISRO, he uh, put some fantastic ideas and use cases in front of us in terms of remote sensing, disaster preparation, and so on. And we look at two perspective in terms of underlying hardware development, where the hardware developers who are not directly dealing with end user, except therefore they are the end users are the application developers, while application developers are dealing with people with diverse range of abilities. And we just discussed the point about marrying these two different points of view, that first should we concentrate on developing technology, or we should look at the diversity of applications in terms of providing accessibility at the beginning. And I'm very glad to see that at this early stage of XR or metaverse, we are talking about accessibility, developing new standards, and I think that will in turn be beneficial for uh, wider range of users, and we will have more inclusive metaverse systems coming along the way. So thanks again to all the participants who are still here. We are ran slightly out of time, and all the panelists for your fantastic sharing of knowledge, and of course the keynote speakers. And we look forward the future development and maybe the next year's conference on similar topics, and we can discuss that what we achieved during the last 1 year. With that note, I will stop talking, and thanks again to TSDSI to organizing this fantastic session. Thank you.
Thank you, Professor Pradipta, and everyone once again. So we will make this recording available on the TSTSA website, and let's continue these discussions. I think there's quite a bit going on in this space, and I'm sure we will, we will meet each other in due course. And thanks again, and thanks a lot to all the audience and the organization committee as well. For setting this up. It's been very flawless. So thank you all. I believe we can close the session now, and take care and have a great weekend that's coming up. Bye bye.